Hi, welcome to Earth Science with Mrs. Miller at BVISD. Today we're focusing on the topographical map and the satellite map, as well as some land features. So what we're trying to get out of this is to be able to interpret topographic maps and satellite views to identify land and erosional features. Now, we also want to be able to predict how these features may be reshaped by weathering. So the vocabulary that we need to look at is topography, topographic map, elevation, contour line interval, and satellite map, as well as relief. The classwork that we're going to be focusing on is being able to do your vocabulary. We're going to label that as Chapter 11 inside your vocabulary notebook. You're going to have a mountain drawing that you're going to do with a mountain model. You have your listening checks, your topography rule book, and a satellite map web quest. Now, you have your journal that with using your mountain model as a guide, you're going to predict how this mountain may be reshaped over time by weathering and erosion. You also want to include how this feature could have been formed and evaluate the advantages and limitations of models. So, topography, what is it? Well, it's the study of the shapes and features of the Earth's surface. And to do this, we use topographic maps. Now, they're 3D views of mountains, rivers, deltas, and other landforms, and other things that, like cities that may be on there. Now, they also give information about elevation of an area in 2D. So if you notice, here we have these things, and these lines that I'm pointing to here are contour lines. And eventually they will form a closed loop. Now, what they determine is elevation. Now, here you see it says 8,600, we have 8,400, 8,800. You're going to notice that these are elevation is feet above sea level. Now, when you look at these, anything within this circle is at that elevation. Now, if you see the difference between here and here, that's the contour line interval. The closer the interval, like over here, the steeper the slope. The larger the interval, like here, the gentler the slope. Now, the thing that you have to remember about these contour lines is that although this does show the highest peak, it doesn't actually show the highest one. That's the highest elevation they can put on the map, but the peak of it is actually a little bit higher. So, same thing for down in here in this nice little, we'll call it a lake. It shows this lowest elevation right here. However, it actually goes lower. So even though the highest elevation line, the elevation technically goes higher, the lowest contour line, the elevation technically goes lower. So contour lines, contour line intervals, elevation, topographic map, and topography, all part of your vocabulary there. Now, we also want to look at these other types of topographic maps. Now, in this particular one, they're using color to designate the relief, the elevation on the map. So, and it's actually sort of cool when they do that because you can begin to understand mountains and lower valleys because they coordinate those colors. Now, on this map, this is a computer-generated topographic map, and you can actually see the layers and how the contours form in here. And these are mostly engineering drawings. They are great to understanding a little bit more in depth. But for actually seeing the features, this type of map and the topographic map that we saw before is what you're going to be looking at. Now, the other type of map that we use to see features of the Earth is the satellite map. Now, all that's happening here is that we're taking pictures from a satellite orbiting the Earth. So these are more picture qualities. So if we look at this particular one, we have the map, the satellite map of the world stretched out and all the impertinent information taken away. So you can actually see color in here where we have Antarctica and all the poles being in white. And you can see some desert regions. You can see the higher mountain elevations here in Argentina and Brazil down in here, but you can also see it in the U.S. and Baja California. So we can see some other types of features with that, but the cool thing about satellite maps always is that satellites can zoom in. So if we take this particular map, So this is a zoomed in satellite map, and we are seeing much more rivers and some deltas going into some larger lakes. And we can see the mountains here as well, and the smaller hills. Now, I also mentioned before that we could see cities. And so this is a satellite map of a city, and we can begin to get the layout of cities and the elevations from there. But you have to remember that although we can identify features like mountain ranges, canyons, rivers and deltas, cities, and even deserts and Greenland or grasslands, you have to remember that all of these can change due to weathering. Now, if you remember from last year, if you had me, we spent a lot of time on weathering. So weathering is anything to do with wind, water, or ice. And then we also have erosion forces that are at work here changing these maps. So let's take a look. Now let's travel a little bit south of us down to Alpine, Texas. In Alpine, you're going to see the Glass Mountains. You're going down 67. And right here, we're looking at the Pecos County, Brewster County line. And you can see all these contours for the Glass Mountain. So let's take a look at this Brewster County map a little bit closer. Now, I'm going to minimize this for just a second. I apologize for the things that's going to go on your screen. So here is a relief map of the Glass Mountains. So you're going to notice here 67 that we're going into Alpine, 90 from Alpine to another town. Anyway, this is the relief map. And if I can switch it to satellite map real quick, you're going to be able to see all this nice relief. And you're going to be able to see, you can't exactly tell the elevations on relief or on satellite maps, but you can definitely tell the significant difference from there. Okay, so back to this topography map, you can see how the relationship goes between this traditional topography map, the relief map from the satellite, and the regular satellite map. So, what we want to look at, what we want to look at is how these things are going to change over time. So, how will these mountains look, let's say, in 100 years? I want you to write in your listening check about what forces are going to cause these mountains to change and what this satellite map is going to look like and what's happening. Okay, so we're going to move on to the Grand Canyon in Arizona. And here you have the satellite relief map. And we have a traditional relief map. And now we have the traditional satellite view. Now, these are different sections in the Grand Canyon. It is a very large piece. But again, in your listening check journal, I need you to take a look and study these features. I want you to determine what effects weathering is going to have on this and what it may look like in 100, 200 years, and so how some of these features are going to change. Now, here's the Mississippi River Delta. Traditional topography map, actually in color rather than elevation contour lines. So you can see how we have a limit of study here, but we do have the Gulf of Mexico in here. So you can see how there's been erosion and no change, and then some accreditation, which means it got larger. Now, here's satellite maps and pictures of the Mississippi River Delta from 1973, 1989, and 2003. So, actually, this isn't going to be necessarily changed by weathering this Mississippi River Delta, but it's been changed by other things. So, in your journal, take a pause, write down Mississippi River Delta, and I want you to analyze how this has changed from 1973 to 2003, so that 30-year period, and what has caused it. How, what, and why. So, thank you for that listening check. So, one more set of regular listening checks. Now there's 7. I know it is a long one. So be sure to pause and write these all down. Sorry about that pop-up. So listening checks. Be sure to write the answers in your journal. We want to know what topographic map rules are for following features: steep slope, gentle slope, streams or valleys, top of the hill, depression, those type of things. What is a topographic map and a satellite map? 2 different answers, A and B. 3. How are satellites and topographic maps similar? And how are they different? That's a compare and contrast. Make sure you have both in there. So, how are land and erosional features depicted on topographical maps and satellite views? This is going to take a little bit of thought, but we did go over it. Just write these in your own words. So, how are changes in elevations shown on topographical maps? And how can land features be reshaped over time? We also want to know how topographic maps and satellite views can be used to predict how land features may change over time. Okay, thanks, and we'll see you next time.